So if you can create a new project in Eclipse, let's say it's week 12, Java projects. So CSE114, week 12, let's say lab exercise 1. If you do that, then I would like you to go to the previous exercise. That should be week 11, lab 1. So you should have somewhere, you have version 1 and version 2, right, from last week, right? Yes. So could you please go to version 2, the one using inheritance, and copy everything except for the student tester. Okay. So, wow, good. You gotta keep this engaging throughout the session, right? What? Yeah, you gotta really remain this. I like it in your engagement. That's good. So you're gonna copy course, non-resident students, resident students, and students. Everything except for student tester. Good. And please drag and drop that into CSE week 12. Okay. And then under source, drag in there. Okay, version 2. So now you should have now. So don't worry about if they don't compile for the week 11. You can figure them out later. Okay. So now we do have under week 12 lab 1 over there. So we have course, we have non-resident students, we have resident students, and we have students. We have these two. Okay. So now let's rename the version 2 to be something else. So let's say if you go to refactor, rename, and then you can say, what about just students? And we're going to create another package called smartphone later today, called the students. Okay, so now for week 12, lab 1, you should have a package called students. Under that, you have course, you have non-resident students, you have resident students, you have students. Okay, so please make sure you can at least go do this. Are we good? Yes. Okay, very good. Very good, very good. Okay, so if I may just remind you very quickly. So we have our resident students class extends the student class. That's one of the subclasses. We also have our non-resident students class also extends the same student class. You can see that in the non-resident students class, we have a new attribute called discount rate. And we also have a new mutator method called set discount rate. Okay, and also we redefine the get tuition method as we did. Okay, similarly, if you go to the resident student class, you have a new attribute called premium rates. You also have a new method called set premium rates. You also try to redefine the method called get tuition as we did. Okay, very good. So now, could you please just create a new class? Let's still call it a student tester. But this time we're going to explore how polymorphism and dynamic binding is going to work. So now, let's say just call it student tester here. Okay, and could you please also create the main method here? Okay, so now let's practice that. Okay, first of all, let's do students say Jin. And if you can recall, did we say Jim now has a static type students or dynamic type students? Static, actually. Okay, whenever you declare the static type, and it never changes. That's okay. So let's put a comment here. So we declare Jim's static type to be students. Okay, that's what we have. So static type never changes, but we may change the dynamic type for Jim. Okay, so let's see different ways of changing it. Okay, so now let's do one thing first, one thing at a time. So now if you say Jim is assigned to, let's say, new resident students, let's say Jim Davis. Let's say we do that. So now you can see that we actually do, so we actually assign a new objects of type resident students to Jim. So you can see a static type of Jim is actually students, and now the dynamic type will be resident students. Okay, so now this assignment here will be valid because if you refer to the lecture notes, when we want to judge to see if line number 6 is valid, first of all, the type for the new object will be resident students. And resident student is a descendant class of student class. So that's why this is valid. Okay. If you look up the notes, it tells you that. Okay. So now you can put a comment here. So now we can say that we change Jim's dynamic type to resident students. Okay. And as we said in lecture, dynamic type may change whenever you like. Okay. And also, let me say one thing more. And Jim's static type remains to be just students. Okay, static type never changes. So guys, we are just creating a new project. So just copy and paste your code from the previous week. The course, resident student, non-resident students, and students. These 4 classes into a new project. Okay, yeah. Or actually, to make it easy for you, or you can just start with your week 11 lab exercise. Just go to a student tester. So we're just reusing all the classes. That can save you time. Okay, so now let's do another one. Let's say if you do gym.equals new non-resident students. Let's say now J Davis. Let's say it's the same student, but the type will be different. Okay. Now what have we done? We'd say change Jim's dynamic type to non-resident students. And also Jim's static type remains still to be students. Okay, if I can spell correctly. Okay, so far so good. You can see Jim's static type remains to be students always, but you can change his dynamic type from resident students to non-resident students. And the reason that line number 9 and line number 13 both work is because the types of the new objects, one is resident students, the other one is non-resident students. Both of them are descendant classes of the student class. Okay, that's why. Okay, so now let's do the following. Let's say we try to do, let me see, what about this? So let's say we create a new course. So course, let's say CSE114 is equal to new course, let's say CSE, just the name, 114. And I believe just another fee, so 500.0. Okay, like that. Let's do another one. So course CSE 11214 equals new course, another course CSE 214. That's also $500. That's how we do that. Okay. So now, right now we're going to do the following. If you say Jim dot register course. Actually, let me do one thing first before I do register course. That might be easier. So what about we just say calculate tuition already? Let's say system.out.println Jim.get tuition. Okay, this line here. And could you please just copy the same line here and just paste it after this. So line number 13 and line number 19, we are doing exactly the same line. Exactly the same. Line number 13 and 19, they're exactly the same. But now we have to use the debugger to see what's going to be the difference when we execute the code. First of all, we know that in line number 13, at this point here, the dynamic type for Jim is simply resident students because of line 12. And in line number 19 there, the dynamic type for Jim is actually non-resident students because of the assignments in line number 18. So the dynamic type are different when we call the two lines. So that means that according to the dynamic binding principle, when we are trying to execute line number 13, we are going to call the version of the getTuition method inside the resident student class. On the other hand, in line number 19, we're going to call a different version of the same method. This time, the method will be the version that's defined in the non-resident student class. Okay, that's the principle for dynamic binding. But let's double check. Okay, so now let's do the following. let's stop here, and then we also stop there. Okay, but let's just step over. So if you can say run, and run as Java application. Oh, sorry, not run. I meant to say debug as. Okay, if you say allow here, so now this is actually, you see line number 12 here, we just changed the dynamic type for gym to be resident students. So now we're trying to call gym.getTuition. So what we expect to see is the version of the getTuition method that is defined in this class here will be called. That's what we expect to happen. If you say step into, and now you can see that we are indeed in the getTuition method here under the resident student class. Could you reproduce that in Eclipse if you try to run it, right? So now we are really in the getTuition, the version of the getTuition in the resident student class, because you see we got a premium rate, which is for resident students only. Okay, so you can simply just do that. And currently, since we haven't set up the premium rate yet, so that's why it's 0. But that's okay. I just want to see the version of the method being called. Okay, let's do another one. Let's say now we are in line number 18 here. You can see in line number 18, we're going to change the dynamic type for gym from resident students into non-resident students. Okay, so after we execute that line, and now for line number 19, we're trying to call the same getTuition method again. But this time, because now the shape of gym has been changed from resident students into non-resident students. So now we're going to call a different version of the same method. But now this method will be defined in the non-resident student class instead. Okay, if you step into it, now you will see we are now indeed in the getTuition method that's inside the non-resident student class, because you can see now we're having discount rate rather than premium rates, right? Do you guys follow? Let's make sure you guys follow this. This is really the first example about polymorphism and dynamic binding. Okay, let me recap what we have done. Okay, and then if you need me to do one more time, I can do one more time. Let's see what we have done here. So if you go back to the tester here, you can see we, in line number 5, we declare a variable called gym. And the static type for gym is simply a students. And remember, in the hierarchy there, we have students, we have resident students extends students. We also have non-resident student extends students. So that means the student class has two child classes. So now in line number 12, we say gym is assigned to a new object of type resident students. That means we are changing the dynamic type for gym to be resident students, whereas the static type for gym remains unchanged. In line number 18 there, we try to change the dynamic type for gym again to non-resident students, but the static type for gym remains the same as well. Okay. So now let's compare line 13 and line number 19 there. You can see 13 and 19 are exactly the same line, exactly the same. So we are really trying to call the getTuition method. Okay. However, because now the dynamic types in line number 13 and 19 for gym are different. In line number 13 there, the dynamic type is the resident students. So that's why the version that is defined in the resident student will be called. That's what we saw from the debugger. In line number 19 there, the dynamic type is simply a non-resident student. That's why another version of the getTuition method will be called. That's what we saw from the debugger. Are we good? Okay, guys? Give me a yes or no, please. Yes? Okay, very good. Okay, that's some basics. So let's do something else. Okay? Very good. So let's do something else here. So let me just remove this breakpoint here. Let's create another student here. Let's say students, let's say Jeremy. Okay, give you some comments here. We declare Jeremy's static type to be students. Okay, that's Jeremy here. So let's create a resident students. Okay, RS, resident students. equals new resident students. And let's say just Jeremy. Let's say Jeremy Gibbons. Okay, that's one line here. And then let's set the premium rates of Jeremy to be, the resident students to be, set premium rate to be 1.5, for example. Okay, let's do that. And also, let's do another line here. Let's say non-resident students NRS equals new non-resident students. Let's also create the same name, okay? Because we're just going to change the status for Jeremy later on. And let's for NRS, let's set the discount rate, okay, to be, let's say 0.5, half price. Now, let's do the following. So let's say we have, let's say Jeremy equals RS. First of all, you have to know why line number 24 will be considered as legal. To actually judge to see if line number 24 will be legal, you have to consider the static types for both Jeremy and RS. Okay? So the static type for Jeremy is simply students, because you can see in line number 20, that's how we declare Jeremy to be. And the static type for RS, it will be resident students, as you can see from line number 22. Okay? So now, for this assignment here in line number 24 to be valid, the static type for RS must be a descending class of the static type of Jeremy. In this case, you do have the resident students is a descending class of students. So that's why it is valid. Okay. So to give you some comments here, so you can say RS static type will be resident students, and Jeremy's static type will be students. And you can say, so now we can say RS static type is a descending class of Jeremy's static type. This is the case because you can see resident students is indeed a descending class of students. That's how you judge to see if this line should compile. Okay, apparently it compiles. And now, if you do Jeremy dot register courses, let's say CSE114, that's what we got. Register course, actually. Register course. And also Jeremy dot register course CSE214, 2 courses. So now, if you do, let's say system.out.println Jeremy.get tuition. So now let me ask you this. At this point, which version of the get tuition will be called? To answer this question here, you have to know what's really the dynamic type for Jeremy. And how do you figure out the dynamic type for Jeremy? To figure this out, you have to look at line number 27. Okay. In line number 27 here, we are trying to assign Jeremy to RS. So whatever the dynamic type for RS is, will be changed to be also the Jeremy's dynamic type after the assignment. And now, what's the dynamic type for RS? For that, you need to look at line number 22, right? Line number 22 there, you have RS is assigned to be as a resident student. So that means the dynamic type for RS is simply a resident student object. And now Jeremy has been assigned to point to that resident student object. That means after line number 27, the dynamic type for Jeremy is also a resident student. So now when we go back to line number 30, so when you say Jeremy.get tuition, it is going to call the version of the get tuition method in the resident student class. Okay, that's how you derive the version. Okay, So this could be a valid actually quiz question. I can say, now, given this code, which version of the get tuition method is going to be called in line number 30? So that's how you figure that out. Okay, let's verify that. So let's put a breakpoint over here. And now let's go for run debug as Java application. Okay, so now we are here. So now if you go into it, you will see that, yes, we are indeed in the get tuition method in resident students, because you can see the premium rates over here. That's the resident students only attributes. Okay, just to show you, but the value is not important. So you can also run the code yourself. Okay, student tester here. And now let's try one more thing here. So now let's say, if you go, so we also have a non-resident students class. So now if you say Jeremy equals NRS. So now, if you look at line number 34, now Jeremy is going to point to wherever NRS is pointing to. NRS is pointing to a new non-resident students objects, as you can see from line 32 here. So that means now we are changing the dynamic type for Jeremy into non-resident students, right? So if you try to do the following, if you say, so now we can do Jeremy.register course, okay, CSE114, and Jeremy.register course, CSE214. And let's say, let me just copy this line here. You say system.out.print line, Jeremy.getTuition. So now compare line 30 and line 37. Okay, these two lines are exactly the same. However, because of dynamic binding, different versions of the get tuition methods will be called. Okay, in line number 30, as we said before, the dynamic type for Jeremy was resident student. Very good. So now in line number 37 there, it's been changed to non-resident students because of line 34. Okay, so now let's verify that. And if we put a breakpoint here, let's see which version of the get tuition will be called. Okay, if you go for run debug as Java application, and now if you get into it, you will see it's a get tuition under non-resident students class, because you can see the discount rate here, which is a non-resident students class only attributes. Okay, so this is sort of the thing you can actually verify yourself to see how the polymorphism and dynamic binding actually work. So now, let's practice the use of the instance of operator. So instance of operator is very good, very useful in terms of checking to see what's the dynamic type for your objects. Okay, so now let's go back to tester here, and now let's do the following here. So let's say, you can say at this point the dynamic type of Jeremy is resident students. So if you do the following, let's say system.out.println. If you do, let's say Jeremy, so this is how you use it, instance of. So that should be highlighted because it's a keyword in Java. And then I want to make sure it is really resident students. Okay, if you do that, it's going to give you true. Okay. On the other hand, let me do the following. If I say Jeremy instance of non-resident students, in this case, it's going to give me false. Okay. So that's something you also have to know how to keep track of. So I might just give you some print statements in the quiz or the test, and then you have to figure out whether that should be true or false, okay, according to the context. So let's just double check. So now let's stop here. Okay, 32 here. If you go to, again, run debug as Java application here. So now we are over here. So if you look at the debugger here, so go to variables. If you look at Jeremy, you can see Jeremy is actually indeed a resident student object here, you can see. So that's the dynamic type for Jeremy. So that is why when you say Jeremy instance of resident students, it's going to give you true. Okay, let's verify that. Yes, so it did print true. On the other hand, Jeremy instance of non-resident student is going to give you false. Right? It's going to give you false. Are we good? Okay, let's try one more. Let's go back to Java here. And could you please just copy these two instances of print statement here? Just copy them, remove the breakpoint, and let's put these two lines over here. So now we are trying to see, after we said Jeremy is assigned to NRS, so now because the dynamic type of Jeremy will change from resident students into non-resident students. So now the result for these two print statement is going to be reversed, because now the dynamic type of Jeremy now becomes non-resident students. So that is why the print statement in line number 41 will be false, and the print statement in line number 42 will be true. Okay, because dynamic type simply just changes, right? Let's double check. Let's go there, and then let's go for run debug as Java application. If you do that, okay, and now, first of all, if you see under variables, you can see Jeremy currently is now, the type is non-resident student. It's a non-resident student object that Jeremy is pointing to. So now if you say Jeremy instance of resident students, it will be false, right? So if you do that, false. If you now do Jeremy instance of non-resident students, it will give you true. Good. You can see those. So this also demonstrates to you how the dynamic type might change for objects. Okay, any questions so far? Any? No questions? Okay. So now let's do another example here. So let's create a new class, something called student management system. Okay, and then again, we want to see how the polymorphism and dynamic binding is going to work. Okay, let's see one more example here before we move on to the smartphone example. Okay, so stop the debugger, go back to Java, and then go back to Package Explorer here. Let's create another class here. Let's say class student management system. Okay, like that. Okay, new class, which contains just one single attribute. Let's say we simply have a student array. Okay, so you can see, as you can see, we are using student class over here rather than resident students or non-resident students, which means because of polymorphism, we can actually assign either resident students or non-resident students to each of the slots. Okay, so now you can put some comment here. Due to polymorphism, we may assign each slot in the array to either a resident student object or a non-resident student objects at the runtime. Okay, we may do either one. Okay. Yes. Which one? Oh, this one? Oh, here? Non-resident student objects, yes. Okay, very good. So now let's just create some attributes here. So we need integer, let's say number of students. So nothing new here, just what we did before. So let's say we have a mutator method here, add students. We're going to add a student object here. So let's say S. So here you can say due to polymorphism, S here can either be a resident student object or a non resident student object. Okay, that's why we just declare students, which will accommodate both possibilities of resident students and non-resident students. Okay, so now we can do students, and number of students is assigned to S. Exactly what we did before for registering the courses. And also, we're going to increment the counter, plus plus. Okay, let's just do that. Okay, good so far? Okay. Okay, so now let's do the following. So I would like to create a new tester class, so just to isolate. So I think this will illustrate also very well polymorphism and dynamic binding. Can we do a new class, just call that students? Okay, that might be too long. Student Management System Tester, how about that? SMS, much easier. SMS tester, and you want a main method there. Okay, so now let's do the following. Let's create two course objects. Let's say two course objects. So course CSE114 equals new course CSE114. Okay, course CSE214 equals new course CSE214. Oh, sorry, forgot. You gotta put what's the amount. Let's say $500. Okay, so now let's create two student objects. One will be resident students, the other one will be non-resident students. So let's say resident students Jin equal to new resident students. And here you can say Jin Davis. And now let's set Jim's premium rates to be, let's say, 1.5. Okay, and I'll set premium rates. Set premium rates to be 1.5. And now let's say Jim.register course CSE114. And Jim.register course CSE214. Okay, let's do that first. Okay, and let's do something similar, just another non-resident student objects. So non-resident students Jeremy equals new non-resident students, and now let's say Jeremy Gibbons. Don't forget a semicolon at the end. And now let's do Jeremy dot set discount rate, because Jeremy is a non-resident student. Let's discount rate to be 0.5. And now let's register the same two courses for Jeremy so we can contrast their tuition later on. Jeremy dot register course CSE114 and Jeremy dot register course CSE214. Okay, so now we got two students. Okay, so now let's create a new object for the student management system. Okay, so if you go back for student management system, we forgot to define the constructor. Let's do it now. So if you go back to student management system here, let's say we have the same name, student management system here. We can simply say, what about just initialize the student array? It's equal to new student, I don't know, 100, for example. Doesn't matter. It's just something here. And then if you, let's put it there. So that's something I'll talk about later on in the lecture, actually. Just put public there, yeah. But let's say if you have some written test, I wouldn't worry about public. Yeah. So number of students, if you like, you can initialize to be 0, but you don't have to, okay? Because default value for integer will be 0 anyway. Okay, we got this. So go back to tester here. So now we'd say students management system here, SMS equals new student management system. It takes no arguments. Okay, so now here comes polymorphism. we can add both resident students and non-resident students. Okay, so we got different shapes basically in the array. So now if you do it, you can say SMS dot add student here. So now we can say Jim is a resident student, right? SMS dot add students Jeremy. And we know that Jeremy is a non-resident student. Okay, so this is exactly polymorphism, because for the same array of students, you can add both resident students and non-resident students. The reason that you can do this is because both resident students and non-resident students, they are descendant classes of the student class. If you look up the notes, the rules are there. Okay, so now, after we have done this, we're going to see how the tuition of the two students are going to be calculated. So if you do the following, for integer I equals 0, I less than SMS dot number of students I plus plus. So now, why don't we just simply say system dot out dot println, and then SMS dot students, which is student array. Let's go to ith position there, which will give you a student object, right? Somehow you would say get tuition here. Think about what's going to happen here. According to line number 21, we added Jim as the first student in the management system. And according to line number 22, we added Jeremy as the second student in the array. So now we're going to call the same method called get tuition on both objects. However, the first student in the array is actually a resident student, and the second student in the array is a non-resident student. So they actually got two different versions of the get tuition method. So now we want to see how exactly they're going to be called. So that's exactly what dynamic binding will do for you. Okay, let me write some notes here for you. Let me write it here first. So let's say, sorry, not here. What I meant to say was here. Okay, let's say here. Okay, Jim is at index 0 of SMS dot students. Okay, and Jeremy is at index 1 of SMS dot. Okay, SMS dot student is actually an array, right? So index 0 will be the first elements. Index 1 will be the second elements. Okay, so now what you want to say here is the first iteration will call get tuition on Jim. The second iteration will call get tuition on Jeremy, right? So now, and meaning that the version of get tuition in resident student class will be called. Sorry, it's a bit long. So I'm trying to make it complete for you. So don't worry, I'll give you time to type it. I'll read it to you again. The first iteration will call get tuition on Jim. Okay, this means that the version of the get tuition method in resident students class will be called. We'll use a debugger to verify this. Okay, so I think this note will be important to you. Okay, similarly, we'll say that the second iteration will call get tuition on Jeremy, and meaning that the version of get tuition in non-resident students class will be called. I'll give you time to type. Okay? Take your time if you want to type. Of course, you gotta study the notes, right? Just typing it wouldn't actually make you understand that, right? Okay, so now let's use the debugger to actually verify this. Okay. First of all, let's just print out. Let's see what's the output from there. So imagine this, because for both Jim and Jeremy, for both of them, they actually registered both 114 and 214. Each one of them costs $500. So that means for Jim, as a resident student, it's going to be 1,000 times the premium rate, which would be 1.5. So for Jim, we should expect to charge him 1,500. And for Jeremy, the base amount will be the same, 1,000. And that will be applied by the discount rate 0.5, which would be 500. Okay, let's see. And if you simply run the program, I think we also got some inflation rate, that's why. Okay, so I believe that's 1.1 or 1.3 or something like that. That's why you see something that's higher, something that's lower. Okay, but let's now verify that we do call different version of the get tuition method. Let's see how we can see that. So now let's put a breakpoint over here, line number 32, on the line where we're trying to call the get tuition method. Okay. So now if you say run debug as Java application. So now we are here. So now if you go to expression here, if you can type something here, go to expression there, SMS dot students I. If you do that, students I, that will give you a student object there. You can see that student there. First of all, you can see that one's SMS dot student I. What's the value for I? Let's see. I is currently 0. Okay, so now that means we're looking at the first elements in the array, and that one has Jim, okay, J. Davis, and he's actually a resident student, okay? And you can see that's a resident student because you have the premium rate attributes in the object, so we are pretty sure it's a resident student object. So now, if we step into it, we must see that the version of the get tuition method in the resident student class will be called according to dynamic binding. Let's go into it. So now, indeed, you can see now resident students, and we are calling the get tuition method from there, right? So that's why we got a premium rate over here, okay? And now, step over. So now, we are now in the second iteration now. So now, again, this line here, you can see now the value of I has been changed to 1. So that means we are looking at the second elements in the array. If you look at the object here, you can see now we are indeed looking at a non-resident student object because we have the discount rate attributes there. So now if you walk into it, you can see now we are indeed calling the get tuition method from non-resident student class. And we are going to apply the discount rate instead. You can see we are trying to run really running the same line of code, but depending on what's the dynamic type for the students, we're going to call different versions of the get tuition method. So that's the point. Okay, so if you run that, it's going to give you another amount over there. So calculate it differently. One would be to apply the premium rates. The other one would be to apply the discount rate. Okay, I think this example here also illustrates dynamic binding and polymorphism quite nicely. Any questions? No? If no, we can move on to the smartphone example. Okay. Good, good. Yeah, it's being recorded, so you can watch that as many times as you like. Okay, let's look at our smartphone example here. So I can just close all the classes here. And then please create a new package here. So new package, and then say smartphone. Okay, plural, maybe smartphones. Okay, so now I have one task for you. Remember the hierarchy that we discussed in the class. So if you go to 114 inheritance, images, smartphone architecture here. So remember that's the architecture we have. Could you please convert this diagram here into Java? For example, let's say, let me show you here. So now in order to somehow translate this architecture here into Java, you can see you have iPhone 6s over here. So you must create a class called iPhone 6s, and that will extend iOS. And also you create an iOS class that will extend smartphone. My suggestion to you would be create 11 classes in your package. Okay, it's gonna be fine. I'm gonna do the same in a moment.
Finish it today.
No, this one is gonna be easy. I'm gonna finish that with you together. Don't worry, don't panic. We have time. Yeah. So create 11 classes here. You got smartphone, you got iOS, you got iPhone 6s, iPhone 6s Plus, Android, you got Samsung, you got HTC, you got Galaxy S6 Edge, Galaxy S6 Edge Plus, you got HTC One A9, you got HTC One M9. You got 11 classes. Once you have done the 11s, you just have to somehow translate each arrow here. Whenever, for example, you have an arrow between iPhone 6s and iOS. For the iPhone 6s Plus, you have to say iPhone 6s extends iOS. And you'll do the same for all the arrows. I'll give you a few minutes to try, okay? It's not that difficult. For each arrow there, as I said in the lecture, each arrow here will correspond to the extend keyword. Okay, I will also do that in a moment. Okay? Of course, I'll do that quickly.
What is that? HTC One A9?
Yeah, One A9, yes. Also HTC One M9. M9, yeah.
Is there any shortcut to create a class?
No.
No.
I'm afraid not. I mean, how quick do you want it to be? Like a Siri? Or like an iPhone? Oh, create a class for me.
That's a good idea.
No, yeah, I know. No. Yeah, you gotta do mouse clicks. Okay, meanwhile, I'll also do that myself. Okay. I'll give you a few more minutes and then I'll do it. And then we're going to play with the types a lot. Or how about this? Let me make it easy for you. Just create all the 11 classes. And then we'll do the arrows together. How about that? 11 classes, I think. Yeah, 11. Yeah. Smartphone, iOS, Android, iPhone 6s, iPhone 6s Plus, Samsung, HTC, and then 4 at the bottom there.
Is that dollar? Like Galaxy Dollar 6Edge?
No, Galaxy S6 Edge. Well, that's the name. That's just nothing I can do about it. That's the name of the phone. I wish I have a shorter name, but that's the name I got.
How about Galaxy S6? Just S.
Yeah, you can say S6 and also S6 Plus. How about that? Doesn't matter. Okay, got 11 clauses, and then I'll also do that quickly myself. Okay, so let me do it quickly myself. Bear with me for a few minutes, maybe. Smart phone, and I have iOS. Thank you. Very good. And Android. I'll go level by level. Android, I have. Under iOS, I got iPhone 6s Plus, iPhone 6s. I also got iPhone 6s Plus. This plus Samsung, thank you. Samsung and HTC. And also I got HTC. Here I got So it's a galaxy ES6H. Okay, I'll copy that name. So, and then I have another one over here, plus. Okay, and then now for HTC, I got the 1A9, right? Thank you. Okay, I got another one. That will be M9. Good. Okay, now, how do we translate the edges into each one of the extents? First of all, let's go bottom up, okay? So now iPhone 6s should extend iOS, right? And iPhone 6s Plus should extend iOS as well. iOS should extend smartphone, right? And now let's now go for Samsung model. Galaxy S6 Edge should extend Samsung. And another Galaxy model here, the Plus model here, should extend Samsung. And if you go to Samsung there, that should extend smartphone.
Isn't it Android?
You are absolutely right. Right. That should be Android. Did I create Android? I didn't. I did. Okay. Very good. Thank you. The Samsung extends Android. Okay. And now Android extends smartphone. Okay, let's now do the HTC model. HTC1A9 extends HTC. And also HTC1M9 extends HTC. HTC extends Android. Okay, and then Android extends smartphone. We did already. Okay, so now we got everything. 11 classes. Okay, that's exactly the handouts we got last Friday. Okay. Okay, let's see what we can do. Okay. First of all, let's do some polymorphism test before we get to the dynamic binding. Okay, let's do something simple first. Okay. Let's do a smartphone tester class. So right click, class, smartphone tester. Okay. Let's say I would like to create a variable called my phone. Let's say I have no personal preference whatsoever about what smartphone I'm going to get, as long as it's a smartphone. Okay. In this case, I can certainly choose the most general class in the hierarchy, which will be smartphone. Smartphone over here.
They're supposed to be main class. Main
You're absolutely right. Thank you. You're absolutely right. There you go. Good. What's wrong here? Okay, smartphones. So why do I have that? Okay, good. So now, my phone is actually a smartphone. So now, tell me if this will be valid or not. Let's say we create a, what about that? iPhone. So if you, iPhone, what about iPhone 6s Plus? IP6s Plus. Okay, equals new iPhone 6s Plus. So that's something I didn't tell you before. So in Java, let's say if you didn't declare any constructor, so there's a default one you can always use, which does nothing. So that's something you can use. Okay. But just for the purpose of testing, so that's why I'm using the default constructor. Okay. So now, let's do another one. Let's say we do Galaxy S6 Edge, Galaxy S6 Edge, new Galaxy 6SH. Let's do another one. Let's say HTC. HTC, let's say M189, for example. HTC 1, it's hard. 189, whatever name you like, is equal to new HTC 189. So now we actually got 3 phone objects. We got 3. So, question for you. What's the static type for my phone? Static type. Static type.
Smartphone.
Smartphone, very good, because static type is whatever you declare the variable to be. So according to line number 5, the static type for my phone will just be smartphone. Okay? Tricky question. Currently, what's the dynamic type for my phone?
Smartphone.
Dynamic type.
Still smartphone, is it?
Nope, because you can see we didn't initialize my phone yet, so it points to null. So dynamic type for my phone is simply nothing. We don't know yet. Okay, very good. So now let's do the following. If you do my phone is assigned to IP6S plus. Okay, apparently this is allowed, but why? How do you judge to see that this assignment here should be allowed? Class of smartphone. Very good. Exactly correct. Yes, yes. Very good, very good, very good. So to make it a little bit more precise, so you gotta see what's the static type for IP6S plus. That one, the static type would just be iPhone 6S plus, according to line number 7. And the static type for my phone, according to line number 5, it's a smartphone. So that's exactly what you said. So one is actually a descendant class of the other. Okay, that's how we judge. Okay. So now, so that's why this is allowed. So now, if you do the following, if you say system.out.println, if you say my phone instance of, okay, just check to see what's the dynamic type for my phone. If you say that's iPhone 6S plus, that should give you true, right? On the other hand, let's see, let me just try all the other possibilities. What about Galaxy S6 Edge? That's another possibility here. And now let's try another one, HTC189. Okay, like that, right? Okay, so what would you think will be the output for these 3 lines? 12, 13, and 14. True, false, false. Exactly. Very good. Let's verify that. Let's try that. And that would be true, false, false. Exactly correct. Exactly. Okay, let's do something else. Now, let's change the dynamic type for my phone. So you say my phone is assigned to Galaxy S6 Edge. Okay, let's just copy these 3 lines over here. So now, what will be the outputs for these 3 lines?
False, true, false.
Aha, very good. Let's verify that. Yeah, false, true, false, exactly. Okay, you can now imagine what's going to be the next step I want to do. I want to change another, to change that to another dynamic type. Yeah, I know it's tedious, but I thought that might be the the only way for you to learn. So let's just do it. So my phone equals HTC that and do again. Exactly, exactly. Yeah. So first of all, true, false, false, and false, true, false, and then false, false, true. As you can see, there's only one dynamic type at a time. Only one. Cannot be more than one. Okay, that's about polymorphism. As you can see, you can change the shape of the smartphone. Okay. Now, let's do something else. Let me do something that's trickier for you to figure out. Okay, so now what about I do the following? So let's say if I do iOS, let's say iPhone, any iPhone, just iOS. And now, let's say if I do iPhone equals Galaxy, let me do that. So remember when we declare this, we actually say Galaxy S6 Edge is actually of type Galaxy S6 Edge, right? So now tell me why this line here wouldn't compile. If you see the eclipse here, somehow it cannot convert. Okay, this doesn't help too much.
They're not descendant or ancestor class of each other.
Okay, very good. So let's have a look at the diagram here. So if you see the diagram here, somehow we declare iPhone to be of this type. And you're trying to give something that's over here, which is not a descendant class at all, right? That's why you want to compile. Very good. So you really have to understand descendant and ancestor classes. Very important. Okay, so now let's do, that one's actually quite easy. So let's try final things for today. Okay, let's think about how we can use the toString methods to illustrate dynamic binding. Okay, remember we actually got, let's say we're going to focus on the 6 different models of the iPhone, Samsung, and HTC. Let's say we're going to do those. So 1, 2, 3, 4, 5, 6. Let's go to, let me just close all the classes, otherwise I'll be confused. So close all. So first of all, let's go to iPhone 6s. Okay, remember the toString method is actually inherited from the object class, so we can feel free to redefine them if we like to. So now let's do it. So you say public to, string to string. Okay, and now you can simply say return. You can say iPhone 6s. Just return what phone it is. Okay, so if I can spell correctly. Just that, as easy as that. Just return identity of the phone. Okay, so please copy this block of code and let's go to iPhone 6s Plus. Now we're going to redefine the toString method there with, actually I shouldn't. iPhone 6s Plus. Okay, so far so good? Okay, let's now go to Galaxy S6 Edge. And now we're going to change that to Galaxy S6 Edge. Go to Edge Plus. I'm going to do that. Galaxy S6 Edge Plus. Okay. Go to HTC1A9. There. You're going to change that to HTC1A9. Okay. So you can see we just redefine all the toString methods in different classes. And finally, go to HTC1M9. HTC1M9. Okay. So now, let's do the following. Let's now do something here. Okay, let's do it. Let's just doing the tester. Okay, just for simplicity. So since we only got 10 minutes left, let's go back to the smartphone tester here. Okay, and now go to smartphone tester here, and please just comment out all the print statement here so we can avoid distraction. Okay, what about this? Let's say we have something like this. We'd say, let's declare an array of smartphone. Let's say my phones. Okay. Let's say that's equal to new smartphone. Let's say I got, let's say 6 different phones. Let's say 6 words, doesn't matter. Okay. Okay, so now I'm gonna say my phones 0 is assigned to, so I got iPhone 6s Plus already there. Okay, my phones. You know, I think for illustration, let's just make it 3. 3 will be enough, actually. 0, 1 equals, and then Galaxy Okay, that's a galaxy model, S6 edge. And also my phones 2 equals HTC 189. Okay, so now line number 27, 28, and 29. Does it illustrate polymorphism or dynamic binding? Which one? Somehow you can see the shape of the my phone. Each slot of my phones can either be iPhone, can be Galaxy, it can be HTC. So different shapes. Is that polymorphism or is that dynamic binding? Come on, come on. Polymorphism or dynamic binding? If you don't know, take a guess.
Which one?
Which one? Line numbers 27, 28, and 29. Does that illustrate polymorphism or does that illustrate dynamic binding? Yes. Yes, exactly. Good. Very good. Because you can see when we declare the array, we say that each one of the elements should be a smartphone. But now we are trying to assign to the first slot a iPhone, the second slot to be a Samsung, and the third slot to be a HTC. So different shapes of the object. So that's exactly what polymorphism is about. Okay. Okay, so now let's see how dynamic binding can work. So now can we do the following? So let's say run a loop for integer I equals 0, I less than my phones dot length I plus plus. And now if you do this, system.out.println and my phones I dot toString. Again, we're going to see dynamic binding because the phone objects in the first slot will be an iPhone. So that means it is going to call the version of the toString method in iPhone 6s Plus. And the second, in index 1, the second slot in the array is actually Galaxy phone. So that means it is going to call the toString method defined in that particular class. We're going to see that. And also, the third object will be the HTC. So that means we're going to call the toString method version there. Okay, let's verify that from the debugger. Put a breakpoint here. Okay, and then let's run a debugger. Run debug as Java application here. First of all, let's just go to the variables here. I can delete the previous one. We don't need that anymore. So, sorry, I just want to delete that. Remove. Okay. Yeah, I is currently 0. That's good. So can we just double check to see, first of all, if you go my phones as an array, if you expand that, you're going to see that, actually that shows very well. You can see that's exactly polymorphism because you can see at slot number 0, we do have an iPhone 6s Plus object. Slot number 1, we got Galaxy S6 Edge, and slot number 2, we got HTC 1.9. Okay, that's exactly what polymorphism is about. Okay, now, currently the value for I is equal to 0, which means we're looking at this iPhone 6s Plus object specifically. And we're going to call the version of the toString method that's defined in this class. Okay, if you say step into, so now you will see that we are now indeed in the toString method in iPhone 6s Plus, right? That's the first iteration. If you do that, and it's going to print out iPhone 6s Plus for the first iteration. So now we are going to the second iteration there. Now the I value will be incremented to 1. So that means we're going to look at the second object in the my phone, which is a Galaxy S6 Edge. If you step into it, you're going to see that now we're going to call the toString method a different version, the version that's defined in a different class. Okay. If you do that, and you're going to see a different string being printed. Okay. Finally, if you go to the third iteration there, so now you can see the I value now would be is actually 2. Okay. Anyway, we're done. Okay. So now let's do it again. So if you go back to Java and say run as Java application, that's why you will see these are the 3 phones in the collection. Okay. You can see they're using a different toString method. Any questions today? So I try to give you something not so difficult. So, but there are many other details you have to follow in the lecture notes. So please try the eclipse and then also try to study, maybe start from what we did today. So these are the basics for polymorphism and bending binding. Okay, and these topics will not be covered on Friday's quiz, not yet. Next Friday. Okay, so you do have time to study and ask me questions. If you have no more questions, then I'll see you on Wednesday, I think. Okay?
When do you get our grades for assignment?
What?
Number one.
I'm still waiting for the TA actually, so he's getting a little bit slow. I'll try to push him. I did already actually. I'll try further. Okay, I'll see you later.